Hello and welcome to this Networking Basics 2 video to talk about routing or how packets can reach its destination. In the previous videos, we examined the fundamentals of the IP protocol, including IPv4 and IPv6 headers. In this session, we will focus on IP addressing, prefixes, and the routing process. Every device connected to the internet, such as a computer, smartphone, or sensor, requires a unique IP address. Currently, both IPv4 and IPv6 operate simultaneously on the global internet. IPv4 addresses are 32 bits long, allowing for approximately 4 billion unique combinations, most of which have already been allocated. To address this limitation, IPv6 was introduced. It uses 128-bit addresses, written in hexadecimal notation and separated by colons, providing an almost inexhaustible address space. Within the Internet model, Layer 3 is responsible for end-to-end packet transport, that's from source to destination. Packets are forwarded across a network of interconnected routers, typically managed by Internet Service Providers or ISP. Each router inspects the destination IP address and determines the next hop, the next network interface through which the packet must be sent. This decision-making process is known as routing. Routers make forwarding decisions based on entries stored in a routing table. IP addresses has a prefix to help routers to determine the next network interface through which the packet must be sent. Each entry corresponds to an IP prefix, which represents the network portion of an address. Prefixes are expressed using the slash notation. For example, in IPv4, where IP addresses are 32 bits long, we can define a prefix as 10.3.8.022. The slash 22 means that the network part is 22 bits long, then the host part is 32 minus 22, that is 10 bits long. In IPv6 is exactly the same, having longer addresses of 128 bits. In this example we have an /64 prefix that defines a network with 64 bits and a host part of the address with 64 bits too. Prefixes play a crucial role in the routing decision algorithms. In IP routing, the network device, known as router, must take a decision for each IP packet they receive where to send it out. The router has a routing table containing prefixes of networks. Here we show an example of a routing table with two prefixes, one /16 and the other /24. With this information, the router must take a decision regarding the packet with destination 198.51.100.17. We could think that both prefixes match with the incoming IP destination. In that case, the router takes the one having a more specific prefix, which means a larger prefix, which in our case is the /24. Then, it forwards the IP packet through that interface. However, routing tables used to contain more than two entries. Let's see a bit more complex example. In that case we have a router with 5 interfaces and a routing table with 5 entries. First, we must sort the table by prefix size, from larger or more specific to smaller prefixes. Then, we have an entry IP packet with destination address 198.51.100.17. We try to match the destination address to the routing table entry by entry. For the first entry, we apply the net mask of /24 to the IP address. This can be done easily using the network mask of 255.255.255.0 and with a logical AND to remove the host part. So, the network part of the address is 198.51.100.0 does not match with the first prefix of the table 192.0.2.0. So, we need to perform the same calculations with the second entry. We move to the second entry and do the same calculations. The mask is the same, /24. Then, we can see easily that the second prefix do match with our incoming IP address. So, the incoming IP packet will be routed towards the left interface of the router. We have defined the next hop for that packet. In the next router, the same calculations will be performed. Now, the question is, how are those routing tables properly filled to define the right interfaces? Routing tables can be filled in two main ways: static routing, where routes are manually configured, suitable for small or stable networks. However, static routing does not scale up. Dynamic routing, where routers must automatically exchange information using standardized routing protocols. So here routers talk to each other to fill and update the routing tables in a distributed way. The most common routing protocols include BGP, Border Gateway Protocol, used for interdomain and large-scale internet routing; OSPF, Open Shortest Path First; and ISIS, Intermediate System, commonly deployed within local area networks or internet service providers. RIP and EIGRP, which are older and less widely used today. We suggest you to take other Nano MOOCs to learn about those routing protocols, especially BGP. In summary, routing is the process by which packets traverse multiple networks from source to destination. Routers use IP prefixes and routing tables to identify the optimal path, ensuring efficient and reliable data forwarding across the internet. Thank you for following this Networking Basics 2 video on routing principles in IP networks. I look forward to seeing you in the next session.